Hello, my name is Michael Kim, and this is my lab report 2 for Physics 2212. Okay, to start, similar to last lab, this lab's purpose is to use pieces of tape to experiment with and calculate electric forces between two objects. The fundamental principle that this lab aims to explore is the electric force between two charged objects. In order to calculate the electric force between two pieces of tape, and the total charge between the two, we are creating a scenario at static equilibrium with gravity opposing the electric forces. One major difference, however, between this lab and the previous is that the charge is not a point particle, but is instead a line of charges. As for assumptions and observations for this experiment, the gravitational acceleration is set to 9.8 meters per second squared. There is no air resistance present in the calculations for this lab. The mass of the tape was 1 gram per meter of tape, and both pieces of tape hold a charge. The observations that were made when I was performing the experiment were that when brought towards my hand, the tape was attracted. When brought towards another piece of tape, the two pieces were repelled by each other, and my tape was able to be moved about 5 centimeters in the air when levitated above another piece. The majority of this lab was focused on the coding aspects, and the purpose was to find and calculate a line of charge rather than a singular charge. As the image shows, the result is a series of point particles that combine to make a singular field that represents the electric tape, and the fields point in a radial fashion due to the origin being inward from the observation location, which is why you see a U-shaped at the top of the points. As for the code itself, this image shows the most important aspects of the coding section, and it is a iterative loop that goes through each individual point and provides a field for that point. As for the results of the coding section, the magnitude of charge on one piece of tape as calculated through the coding was 1.962 e to the negative 3 newtons per coulombs. And as previously stated in the assumptions, we ignored air resistance from when the piece of tape was moved upwards, and we assumed that on each line of charge there was an even distribution along both pieces of tape. As for what would have happened if I had modeled each of my tapes as a singular point charge like the previous lab, the early aspects of my code tended to show this result to be the case due to an error, and that result was off by a magnitude of 1 e to the 6. After fixing that aspect of my code, I believe the error came in the lack of iteration when going through a singular point charge, and that was the cause for such a large discrepancy. Because of this large discrepancy, I believe the charge of the tape as a line of charge is way more accurate as it models the object more closely to the real object as opposed to a singular point charge. And similarly, if the field was iterated as a plane rather than a line, that would give a more accurate representation as it perfectly resembles the real-life object.